It's great the conference are bringing us into one time zone, and I'm very pleased to have this opportunity. And my talk today is about sustainable soil use and management, and I want to give it some thought and talk about a systematic approach which we may be able to use to better achieve sustainable soil use and management. First, I want to show you a graph. This is the number of publications that has been indexed by Science over the last 2 decades or so. As you can see, the number of papers published on the topic of soil and sustainability has grown dramatically over the last 2 decades. A similar trend happened to the keyword soil health. Overall, we can see that even though traditionally we are mainly concerned about productivity, soil fertility, and also soil pollution, but in the most recent years, people are increasingly concerned about the overall sustainability and the health of soil systems. And by looking at publications from different journals, from different disciplines, we can find that studies on soil really comes from a broad spectrum of study areas. And for the conference attendees, most of us are probably coming from the environmental science and engineering field, and we mainly look at soil pollution by heavy metals. However, we can reflect, soil pollution is largely caused by anthropogenic activities, and that is driven by human behavior and management practices, which falls under the social science umbrella. And then there's this traditional perspective from agronomy, look at the soil fertility. And also during the recent years, probably the biggest environmental issue is climate change. And soil is the largest carbon pool in the terrestrial system. So soil carbon from the climate science also play a pivotal role. And then there is soil biodiversity from the ecology perspective. Overall, all these aspects count. And when we look at the soil system, we have to take all this into account. Now, I want to talk about these individual systems. First, about soil pollution. The effects of global soil pollution is multifaceted. First, it jeopardizes public health. Globally, we have been doing a lot of soil remediation, doing risk management. All these have a common goal of minimizing the detrimental health effect of heavy metal in soil. However, soil pollution by heavy metal also have other problems. For example, it can threaten food production. This issue is particularly serious in China. There are large agricultural fields which have been contaminated by heavy metals. And a lot of agricultural fields probably need to be converted back into forest or for other purpose. Then this basically threatens food security. Similarly, heavy metal contamination can reduce primary production and carbon capture by the biological systems. And it also deteriorates ecosystem and biodiversity. In China, the national government published a soil quality survey report in 2014. It suggested that 16% of the soil samples exceeded the pertaining soil quality standard. And that is the overall ratio. For industrial site, it's nearly 36%. For agricultural soil, it's 19%. As you can see, these numbers are astonishing. And the government released an ambitious action plan in 2016, which was calling for hundreds of billions of yuan in investment for the management and cleanup of contaminated soil. And it was expected to stimulate 3 trillion yuan, which is equivalent to nearly 500 billion US dollars of GDP growth. However, the current practice in soil remediation have overly focused on human health. It's even more biased toward the concentration versus the actual health impact. In my view, the current method does not fully meet sustainability principles. So I have been advocating for green and sustainable remediation for several years since I came back to China several years ago. I believe green and sustainable remediation is the way to go to address soil pollution. Historically, the remediation industry started in the Western world back in the 1970s. In the early days, people wanted to remove all the contaminants, the last drop of pollution, which was becoming clear is impossible. And then people came up with a risk-based cleanup approach. But in the most recent decade or so, people in Europe and the US have come to realize that a sustainable remediation should be a new trend. We have to take into account life cycle secondary environmental impact, try to use nature-based solutions, and try to reuse soil and groundwater resources and enhance the resilience of remediation systems. Moreover, soil pollution is linked to a number of sustainable development goals by the United Nations. For example, for SDG 1 and SDG 2, which are no poverty and zero hungers, soil pollution clearly poses a challenge for small farmholders who grow staple food on small agriculture field. And with pollution, they, on the one hand, may lose source of income. On the other hand, they also have a reduced crop yield. So the imminence of hunger apparently becomes more serious. To address this, soil fertility is a key. However, traditional remediation approach, for example, solidification and stabilization, when we use that kind of approach, we lose soil function, its capability to grow food or other vegetables. So when we try to remediate the industrial land, we will have to think about this as well. I mean, one example is that in China, some contaminated industrial land are being converted back into agricultural land. And for those, apparently, we have to think about the soil fertility when we do remediation. And in the 2016 action plan published by the Chinese government, we were going to finish detailed investigation by 2018, which we did. And also the plan was to clean up nearly 1 million hectares of contaminated land, which is still ongoing. My question is, I mean, how can we make this practice more sustainable? For example, one big concern of experts as well as policymakers is we are still not super clear how most of the agriculture fields were contaminated. Without that knowledge, how can we make sure after the remediation, there is no new pollution? So that is a serious concern. So prevention must be a key. I mean, for future management of these agriculture fields. And also in China right now, there is a big debate, I mean, between the choices of phytoremediation versus stabilization. There are not many choices really, I mean, for the remediation of agriculture field. Unlike for industrial side, I mean, we have a big toolbox, but for agriculture field, it's more difficult. Apparently, if we do phytoremediation, it often takes a long time, and that poses a challenge to agriculture production and its economic feasibility. And for stabilization, its long-term effectiveness is questionable. I mean, do we need to reapply stabilization reagents once every few years? And these are big problem question marks. And then there comes soil carbon. I mean, soil organic matter is a very critical carbon pool. Shallow soil stores nearly 2,000 gigatons of carbon, and the permanent frozen soil stores another nearly 2,000 gigatons of carbon. So considering that there is only about 800 gigatons of carbon in atmosphere, this is, I mean, almost 5 times as much. So it is important to manage soil in a sustainable way in order to address the climate change issue. And the global initiative called 4 per 1,000 is one of the initiatives which is aimed to use soil as a tool to address climate change. And I think, I mean, biochar, I'm sure it's probably a hot topic in this conference, is another potential tool to address climate change. There are additional concerns or considerations in remediation. When it comes to soil remediation, there are impacts associated with the land itself, those associated with the remediation operation, as well as those associated with the post-remediation usage of the site. Recently, I did a quantitative assessment for the city of San Francisco. What I found was that by doing accelerated remediation and in a sustainable way, we can reduce the greenhouse gas emission by nearly 20% for a city, which is a very big number. So I think soil remediation can really make a difference in this global combat against climate change. Next is soil biodiversity and soil health. In the past, when we deal with soil remediation at an industrial site, people rarely look at it as a living system. And for example, we do thermal treatment. I mean, we're using very high temperature. We add very strong oxidants to degrade the organic matter. Those techniques are quite aggressive, and one would wonder whether they will kill the microbial population as well as soil animals, thus reducing the soil biodiversity, or I mean, has a degraded soil health after remediation. Apparently, this is something that we have to look more into in the future. Here, I just give a few examples. Thermal method I just talked about, chemical oxidation. Also for stabilization is similar. I mean, traditionally, cement is widely used. It's probably the most widely used stabilization, solidification, and stabilization reagent. However, I mean, it changed the pH dramatically. Evidently, that could have a big impact to the biological system. toward the end, I want to talk about the management behavior. I think the technology never provide a solution by itself. Ultimately, it is upon people who use the technology to make a difference. So when I look at the soil pollution issue in China, I think we have to take a holistic approach. We need to look at the polluting behavior. I mean, what can we do to change those behavior? And what's the public trust? I mean, how to make people believe we are doing the right thing when we do soil investigation and remediation. And then when we do investigation, where do we store that data? How do we share that knowledge? And that data can be very valuable for scientific research. And all these make a difference in sustainable soil use as well as sustainable remediation. However, right now, I think information sharing, disclosure are not done in the best way. So this is also a direction I think we have to make more progress. Just a few final remarks. First, I think soil is pivotal in meeting the United Nations Sustainable Development Goals by 2030. Soil pollution has multifaceted effects. Remediation must take into a number of different sustainability considerations. Therefore, an interdisciplinary approach is required. Before I close, I just want to advocate for my research institute, Tsinghua University. It has a history of over 100 years. Currently, it's ranked #1 in China, #3 in Asia, #15 globally, based on the QS ranking. And its environmental science discipline is ranked #9 globally. I want to welcome you all to visit Tsinghua in the near future. Actually, we are organizing the third Tsinghua Forum on environmental remediation. We tentatively plan to put this conference for May 15 to 16 in the next year. It will be a combination of online and on-site meetings. So you're welcome to visit this website and to find more information. Again, thank you very much. I hope we'll find a chance to meet each other soon. Thank you. Bye.
Okay, thank you, sir.
Okay, thank you very much.